Now that we've gotten familiar with the coordinate plane, let's look at graphing and equations. Remember, what makes this an equation is the fact that we have an equal sign. And when we talk about the ordered pairs, when we're graphing, what we want to do is find what ordered pairs, what x values pair up with what values that make the two sides equal. That's where graphing ultimately comes from. We're going to try graphing this in a few different formats. The first of which, I want to get us used to making a table. The table may seem like a little bit of extra work right now with different ways that we can graph. This is going to be a linear equation. We're going to show an easier way to graph this equation right after. But for right now, I want to give us a good foundation with how to make a table and what a table means. Because with some of our graphs later, we won't have very simple direct ways. We're going to want to make a table using the same format that we're doing right now. Now, if you remember the names that we have for the x and y, it is the domain and the range and what's allowed and what's not allowed, but we won't cover a lot of that. Again, the descriptive terms. X is what's called my independent variable. I can pick anything that I want for x. Independently, I want to pick easy numbers. 0, the easiest number we can pick. 1, very easy. 2, very small. The reason I may even avoid picking a 3 right now, we're going to find out later that numbers like 3 can sometimes even run us into some very large numbers that are very difficult to graph. Sometimes -1 or -2 can be much friendlier numbers just because negative might have to deal with signs, but may still keep numbers very small and very easy to graph. I get to pick anything that I want for x. Remember, it's called my independent variable. Also called my input variable. That x value is what I'm just going to plug in. I'm just going to substitute it for x. That means y is going to equal 2 when I plug in 2. Substitute in parentheses. Have a plus 3. Well, remember, 2 times 2 is 4. Plus 3 is 7. That's my y value. When I plug in x, that is my output. But remember now, the other name, if x is my independent, y is what's called my dependent. Remember, these are very descriptive terms. That 7 depended on that 2 being plugged in. Those are descriptive names of plug in an x, I get to pick it independently. My y value is going to be the output that depended on what I plug in. They're very specific. Now, when we talk about the ordered pair, remember we're ordering an x value with a y value. There's my xy ordered pair, meaning on the graph of this equation, ordered pair, and now it's still just like we talked about last video, 2 to the right, 7 up because they're both positive. That's an ordered pair that's going to be on that graph. Now, we wanted to pick all these other easy values. Let's plug in 1. Substitute it. Unrelated to that 2, but it's going to be the same equation. Plug that in. 2 times 1 is 2, plus 3 is 5. Remember, that 5 depended on that 1. That 5 is the output when I plugged in the 1. I independently picked. That 1 I just picked because it's an easy number. But when I plugged it in and when I got the 5 out, that gives me another ordered pair, 1, 5, which then on my graph, 1, 5. These ordered pairs, and it's the collection of these ordered pairs, which is what we use for graphing, and that's what every graph, whether it's this linear function, whether they're quadratic or exponential or rational, whatever other kind of graphs you're going to see, all graphs fundamentally come down to the same idea of a table. And I could plug in anything. I picked 2 and 1 because they were easy. I could have picked 1.5. I could have picked 1.73 for x and plugged in if I wanted to. I'm deliberately, independently picking anything I want, easy numbers for x. I'm plugging them in, and I'm getting my y values. And here's 0, the easiest number there is, because anything times 0, 2 times 0 is 0. Anything plus 0 is itself. 0 plus 3, 3. Giving me ordered pair, 0, 3. Which remember, 0 from an x means don't go left, don't go right. I'm just going 3 up. There it is. And remember, this is what's called, if you want to know its name, the intercept. Anytime a graph crosses an axis, it would be the y-intercept because it's on the y-axis. It's where it crosses the y-axis, called the y-intercept. We'll talk about it here in a minute. Let's plug in that -1. We talked earlier about how plugging in a number like 3, some of the graphs, that's going to be very large and it's going to be very difficult to try graphing. But watch what happens to that -1. 2 times -1 positive times a negative. Anytime it's different signs, I get a negative 2. Plus 3, if I owe $2 but make $3, I still have a buck. But remember, that's an ordered pair. Negative 1 when I plug it in for x, 1 was what I got out for y. Negative 1 to the left, 1 up. When I plug in that negative 2, 2 times negative 2, same as last time. 2 times negative 2, positive times negative, anytime it's different signs, negative 4. Negative 4 plus 3, if I owe $4 but make $3, I still owe money, so it's going to be a negative 1. When I plugged in negative 2, I got out a negative 1. X is negative 2, means 2 to the left. Y is negative 1, means 1 down. There's my linear equation. Any ordered pair that's on this graph, and just like when I said that 1.73, that horrible number, if I plug in 1.73, whatever that horrible, ugly decimal is, that's going to be that pair when I graph this. Tables are the fundamental way that we can always graph, even if we don't know how. And we're going to see tables later.